Welcome everybody, it's Amel, and today we're going to solve binary tree right side view. Given a binary tree, imagine yourself standing on the right side of it. Return the values of the nodes you can see, ordered from top to bottom. So here, we're given a binary tree. This is an example, and this is the binary tree. So imagine yourself standing right here on the right side of the binary tree. You have to return all the values that you can see from this place. So you can see value 1, you can see the 3, and you can see the 4. So that's the output, 1, 3, 4. So from this place you cannot see value 5 because the 4 is blocking the 5. Similarly, you cannot see value 2 because the 3 is blocking the 2. So how can we solve this problem? So what we have to do in this problem is to find the last node at every level in the tree. For example, this is the first level. The last node is 1, that's the only node. In the second level, the last node is 3. And in the third level, the last node is 4. So that's what we have to return. That's why we return 1, 3, 4. Those are the values that we can see from the right side of the binary tree, from here. So we can perform breadth first search. We can perform a level traversal of the tree. We can perform a level order traversal of the tree. So we can use a queue that has the FIFO property, first in, first out, in order to perform the breadth first search. And we go level by level. Each time we find the last node in every level, and we add it to the final, and we put it in the final list, in the final result. So without further ado, I'm going to show you how to write the code. So first, I need to have a list of integer. This is going to be the final result. Now, if the tree is empty, fruit equals null, I just return the empty list. Now, I have to have a queue of reference to node, and I'm going to use this queue in order to perform the level order traversal of the tree. So I have to put the root of the tree in the queue, so queue.offer root, and then I have to kick off the process. So we'll say while nav queue that is empty. So I need to get the size of every level. So I'm going to say integer size gets a value of queue.size. So now this variable has the size of the current level. I have to traverse all the nodes in the current level. So for integer I gets a value of 0, I is less than size plus I. I will remove the current node from the queue. So reference to a node t gets the value of queue.poll. And then if this is the last position, if this is the last node in this level, I'm going to put the value in the final result. So if I equals size minus 1, then result.add t.value. I also have to take care of the children. If they exist, I have to put them in the queue because I want to process them. So if t.left is not equal to null, if the left child exists, then queue.offer t.left. Also, if t.right is not equal to null, if the right child exists, then queue.offer t.right. And finally, when the BFS is over, I just want to return the final result. So I'm going to run the code. I'm going to submit my solution. Alright, it's working perfectly. The time complexity is big O of n, where n is the number of nodes in the tree, because we have to traverse the entire tree. And the space complexity is also big O of n, because in the worst case we have to put all the nodes in the tree. That's when the tree is completely unbalanced. So if you like this video, please press the like button. Don't forget to subscribe, and see you next time.